Okay.
Sounds good.
Let's do it. Let's do it. Let's do it. Hello, everybody, going live, and we are definitely live. Data on Kubernetes community live stream number 99. Before we get started, normally we do shameless plugs at the end, but we're going to start doing them in the beginning. Our speaker today is an expert in many things, and we actually have a few things in common. We both play drums. We both went to the same amazing, kick-ass, one-of-a-kind university, University of California at Santa Barbara. Much love to all the fellow gauchos out there. If you went to UCSB, much love. If you didn't, that's okay too. If you are celebrating Diwali today, or if you're celebrating anything today, much love to you. We want to celebrate with you. But just a couple of things that I want to get out quickly about our speaker, Abhi. Something that we don't have so much in common is that he is pretty much a professional gamer. And not only that, has a podcast dedicated to the love of his life, or perhaps second love of his life, which is Smash Brothers. I'm going to drop a link to that right in here. You can check out his podcast. It's super dope. Next thing, moving over to today's topic a little bit more directly. Now, when we talk about the data on Kubernetes ecosystem, universe, etc., we often have the starting point of databases and storage. But if you'll see in the wonderful report that we launched earlier last month before KubeCon, we talk about how the ecosystem branches out into other areas. And what we're going to be talking about today is just one of those. All right. So I'm going to drop the link right here. You can see the specific points mentioned in the report, I believe on page 9, 12, and 16, where it's spoken about the sort of, like I said, data on Kubernetes ecosystem, other things that we find there, such as streaming, such as analytics, machine learning, other things like that that fit into that. So we want to also make sure that those things are being incorporated in the conversations that we're having. That being said, I wanted to introduce Abhi, who's a senior dev advocate at a very, very cool startup called Airbyte. You should all be checking out because they're doing fantastic stuff. Definitely check out their Slack. It's one of the most, actually not one of the most, it's the most dynamic Slack that I've ever seen. Somebody actually blogged about how cool their Slack is set up, and Abhi is very much a big part of that. Abhi, welcome to the Data on Kubernetes community. Very happy to have you with us today. Can you just give us a little bit of background about yourself, about how you got into this space, and then we can see a little bit more about what's going on with ELT and ETL and Kubernetes.
Sure, that was a very gracious introduction. Thank you, Bart. I started this space at actually a cloud native database startup. I don't know if I think you've PlanetScale. So I think you've had Alkin on here.
Yes, we have.
on the show. So that's kind of where I got my kind of first foray into into the cloud native landscape in Kubernetes. And that's where I was really developing. I helped develop the Vitesse operator there. So that gave me kind of like a lot of like really good context, I guess, specifically in the data on Kubernetes space. And then I came on over to Airbyte, and with Airbyte, I was focused on community building, and I got to get enter an ecosystem where the community kind of runs itself. It's like I can take a lot of credit for it, but in a lot of the cases, like there's so many reasons why I think we're all just kind of like supporting each other. Like a lot of the engineers and a lot of our team is just strictly dedicated to helping the community. We've like hired user success engineers, and I think the one of the coolest things about Airbyte is that I think if you come in and ask a question, it usually gets answered immediately, whether that's by a community member or by one of our user support engineers, or by me, or or by any of our engineers. So we kind of take a very joint approach to addressing the community. We're trying to kind of engage them as much as possible. But as far as I go, yeah, I think basically relative to the data on Kubernetes community, it would probably mostly, my interaction with it is mostly due to, I think, interacting on the Vitesse project, attending KubeCon a few times here. I think I got the KubeCon Barcelona t-shirt here. So I think that's about it. I'd say.
Okay, that's still a good start. And obviously we'll save time for drumming and beat making and Smash Brothers later. Really quickly though, because I just one thing I want to mention about Airbyte, shout out to Michelle and also to John, is that because when you're talking about answering questions, and from a community perspective, just a recommendation to folks, like you're in California, I believe you're in San Jose, correct? Bay Area?
That's correct.
Okay, yeah. And I'm in Spain, but interestingly enough, with Airbyte, like really taking this pandemic remote work very seriously, and having a very well distributed global team. And I say that just because I was having Abhi in the West Coast of the United States. And for any of you that don't know this, because I didn't know this until I met Sean from Airbyte, is there's a place called New Caledonia. All right, I highly recommend. I'm serious. This is not a fictitious place. This is a real place. It's in the South Pacific, kind of between Australia and Fiji. Anyway, I'm probably missing the mark there too. Just check it out, just so you can find out and know where that is. And anyway, which I found out about, but not only that, there are fantastic engineers from Airbyte that are well distributed across the planet to be able to respond to those community needs. Because let's face it, you got people all over the world, so being able to provide a quality and timely response to their concerns, and also enjoy the richness of the different kind of backgrounds and experiences that people from different places can provide. So anyway, I think that's awesome. Well, that being said, folks, remember, if you've got questions, feel free to drop them in here on YouTube. If not, we can continue the conversation later on in Slack. Abhi, if you want to take it away, start sharing your screen, go for it.
Cool. Sounds good. Let me pull this up.
Alrighty, perfect.
All right.
And I already got some questions from folks asking just exactly what's the difference between ETL and ELT. So it's nice that your title starts out with that.
Sure. Let me address that first. So essentially, ETL has been around for a while, right? ETL has been around for, I think, more than 20 years, and it came as a need to. It came as the burgeoning landscape of like large amounts of data showed up. We needed to be able to not run our analytics jobs on our production instances. So we needed to be able to like basically move all of our data, whether that's from our production databases or whether from all of our APIs, marketing APIs, sales APIs. We need to basically move all of this data into places that they can be analyzed. And in the current day, that's a data warehouse, but it wasn't always the case. People realized that what ETL as a paradigm requires you to involve a data engineer every time. So you're doing that transformation step in the middle. So ETL, extract, transform, load. So you're doing that transformation step in the middle. So whenever you have to change something about the transformation, or whenever you have to whenever something breaks, you have to end up resyncing all your data. You end up having to kind of rerunning all these transformations. You got to get your data engineers involved. ELT, on the other hand, is more lightweight. Like you can you focus on the EL part, meaning that you extract and load, get all of your data in the destination, get all of your data in the data warehouse, and then with all of that data, you can run your transformations there, which means that if you have all the data, you don't need to kind of get a data engineer involved. You don't need to you don't need to resync your data. So you can just perform all of your transformations there. And with tools now like dbt, I think that's a lot more of a it's a lot more of a viable strategy. And I think over the last like 4 or 5 years, we've really seen ELT be the main paradigm. I think most of the closed source offerings and I guess the main open source offerings, including us, have been mostly focused on ELT and kind of letting other people do the transformation, if that answers that question. Cool. Now let me get into the topic for today. So today I kind of wanted to, for those that didn't catch my previous talk on the data and Kubernetes community, I'm going to be doing a quick recap. But essentially, a while ago, I came on I think I came on during one of the KubeCons, and
you did, and it feels like that was like 9 years ago.
It does. It was 9 months ago, indeed, or something like that. And the thing is, I got to give like a 15-minute, super snappy lightning talk about this.
And you had just started working at Airbyte. You've been working there for like 2 weeks, I remember. Yeah.
Yeah. It was kind of crazy because I came on. I think I think we got this opportunity. You reached out to us, and then I think Michelle and John talked to me and they said, "Hey, you want to give this talk?" And I was like, "Sure."
But you did a good job. It was cool. It was good.
Thank you. And now I get to, I think, follow up on that with a lot more context. And so the really cool part about that I think I was really excited to share is that in the moment we actually hadn't gone into alpha or beta with our Kubernetes support. Actually, it wasn't alpha, but our actual like architecture for what we thought our deployment on Kubernetes was going to look like, I think was completely different. So I think I in that talk, I gave these ideas of what our possible deployment on Kubernetes could look like. And now after we've actually shipped our beta version of deploying on Kubernetes, I can tell you that it looks very different. And I think showing how this design evolved is kind of like a cool retrospective. It's a cool, I guess, way to, I guess, think about very specific things when we're moving from, I guess, simple Docker environments to, I guess, to like fully orchestrated environments. So I think that's the main focus on today, is kind of taking what we learned and then seeing how I guess we moved from that, seeing how we learned from that, and then I think showing what we're going to possibly do in the future. Before I do that, I do want to give a bit of context about what Airbyte is. I want to talk a little about. There's kind of a bit of groundwork to lay, so I'm gonna try and move through that. Let's go ahead and go on to the next slide. So at a high level, Airbyte is essentially a UI in front of a scheduling system that connects data sources and destinations. Whenever you set up a sink in the UI, whenever you go into Airbyte, you're basically asking Airbyte to move data from one location to another. So from wherever you have data to wherever you want to move data into. You can optionally perform in-flight custom dbt transformations because we integrate with dbt. And you can, but at the end of the day, really all I want to focus on is moving data from one place to another. You go into our UI, you deploy either on an EC2 instance, like any type of VM, Azure VM, locally, and you go into the UI and you say, okay, hey, I want to move data from one place to another. And on the back end, we take that request in and that essentially hits our API, and that request actually gets sent to something called temporal. And temporal is essentially a microservice orchestration platform. And temporal is actually what handles a lot of the intermittent errors, retry policies, and scaling, and it will essentially basically ask an Airbyte worker to come up and fulfill that connection job. So the reason I think it's important to go over this context is that every single one of these things that you see here on the screen needs to be able to be ported onto Kubernetes. And there's a lot of kind of like nuances that come with that. So we need to essentially have a pod for the server. We need to have a pod for the scheduler. We need to, I guess, expose the UI. We need to, theoretically on some service, we need to have a pod for the temporal cluster, and we need to have either static or ephemeral pods for the workers. Additionally, we need to have stores or volumes. We need to have like either persistent or like mounted or shared volumes for all the things that you see here, whether it's the temp store, the config store, which stores, and the configuration store, which stores all of the information about what data you've synced, and all of your sync information. And so there's a lot of moving parts. There's a lot of things that we need to think about when migrating this architecture to Kubernetes. And we kind of came and I guess before we go into that, let's just do one quick recap on why we would want to move to Kubernetes and why I think the Kubernetes deployment is, I guess, very viable with Airbyte and is powerful. Our source and destination containers, our source destination connectors are containers. They are completely containerized, isolated pieces of code. And why this is so powerful is that it allows us to I guess, if as long as we can guarantee that the source connector and the destination connector are speaking the same language, we can guarantee moving data from any, we can guarantee and interchange moving data from any source connector to any destination connector. So any source connector, again, such as a database, Postgres, Redis, Elasticsearch, or an API, such as the Salesforce API, Zendesk API, HubSpot API, wherever you have data. And there's an individual source connector that is created for that source. And this source connector, this packaged piece of code, is simply responsible for making sure that it's gathering all of the data that is possibly available at this source. And most importantly, gathering all the information and in what schema this data is available in. So then this source connector will read data in and it will essentially expose what data is available to the destination. And then there's going to be some translation that goes on. As you'd probably think, there's going to be a lot of unsupported data types. There's going to be a lot of type conversions that you're going to have to do. Just in case that there's, maybe you have, like, if you're doing a database to database migration, there's obviously a bunch of conversions that are going to take place. So we're going to have to make sure that, again, the source and destination are speaking the same language. And so we read the data in from the source, we pass it off to an Airbyte worker. If we remember from the previous slide, we essentially we schedule a worker to handle all of these sync jobs. But in addition to that, we will bring up these source and destination connectors very specific to whatever data you're syncing, I guess, from and to. So the Airbyte worker will handle reading the data. Once it's sent out from the source connector, it'll go as what we call a message to the Airbyte worker, and then this Airbyte worker will do any in-flight operations and then pass it on to the destination connector, basically passing on the exact same message. And the destination connector has one job, and that's making sure that it can take in data, as in, like, take in the data from the source and essentially discover the structure and what data is available at the source, and accurately convert that and transform that into the format at the destination. So this is kind of an overview of how the Airbyte sync process works and why I think it's able to be ported to Kubernetes, because everything is containerized. We essentially can map everything to pods, or we can, at the very least, basically run any of these containers as sidecars in other pods. We can run sidecars along along these containers in pods. So having everything containerized, I think, was the first step. And I think most people are familiar with the kind of like the mapping that comes with their Docker containers and kind of naturally bringing them into the orchestrated Kubernetes environment. So as a recap, this is kind of the issue. This is kind of one of the issues that comes into deploying Airbyte on Kubernetes. One of the issues that we first ran into in development is that we couldn't develop the ability to schedule things on different nodes, which just made the idea of going Kubernetes really meaningless. If you can't schedule on different nodes, you may as well just have one big VM and not use Kubernetes at all, because then you're not essentially taking advantage of any of any of the power of Kubernetes, or really basically taking power of that powerful scheduler. So one of the biggest things that we had to tackle was figuring out how to make sure that all of these pods could communicate between different nodes, and that we could schedule anything on a different node. And honestly, large companies are going to be running into basically the issues of having too many sources and too many destinations. So if you try to schedule all of these pods, as I mentioned, there's going to be these connector pods. So there's the source pods, and then there's the destination pods. And then there's going to be the scheduler and the server and all of the Airbyte architecture, temporal. We are going to run into resource issues really quickly. So this is not a really an efficient deployment, and we have to think about how can we communicate across nodes. And as I mentioned before, we want to kind of emphasize why the deployment pattern is powerful. We have our isolated behavior in our source connector, isolated behavior and destination connector, which is that huge prerequisite of going onto Kubernetes. So one of the plans that we had initially, and this is one of the ones that this is one of the plans that I showcased in that talk that I gave about 8 months ago, is that we have our source container, our destination container on the same pod. Now, what is good about this? One of the good things about having the source and destination connector on the same pod is that they can talk over essentially the local network, as opposed to having to send messages over either the Kubernetes network or logs or using any other utilities. This is a pretty big plus. But unfortunately, this actually came with some huge drawbacks that we eventually saw afterward. We realized that if we have the source connector and the destination connector on the same pod, it's going to be really, really bad for scheduling, because we're going to have the worker essentially be located on the same pod. As I indicated before, we need to have all three of those containers when we're trying to run an Airbyte sync, because we basically take the Airbyte message from the source, we pass it off to the worker, and we pass it off to the destination. So we would want to run the worker on the same pod. So we'd essentially have these three containers all on the same pod, which means that if we're trying to, let's just say that we could schedule, let's just say our nodes are maybe like 4 gigs and our source and destination and worker are all like 2 gigs each. This means that we can't have this flexibility of like having the source pod come up, the destination pod come up, and maybe put the worker pods on a different node. We are always stuck to, I guess, provisioning really big node sizes. We're stuck with basically keeping everything within one node, which is kind of one of the issues we wanted to get away from. We wanted to leverage Kubernetes instead of just being forced to schedule everything on one node. So this kind of became, I guess, less flexible as a paradigm. Additionally, we were thinking about intermediate containers. So this is another thing that came to mind, which was, what if we wanted to filter out PII or run a user-defined custom transformation on the messages that are being sent from the source to the destination? We are now restricting ourselves because the life cycle of this operation is now tied to the life cycle of the sync, because pretty much we have one point of failure. So the source, the worker, and the destination are going to basically determine basically everything that we can do around the sync needs to be run in this pod. So we can't run any intermediate containers without first sending the data back out of the pod and then back in, which then completely defeats the purpose of having everything co-located on the single pod. So we eventually realized that even though in theory it would be nice to kind of have everything located on the same pod, it just wasn't an optimal solution. It didn't take advantage of Kubernetes. We would have to send data out of the pod if we wanted to do any kind of intermediate operation, or we'd have to put even more containers into the pod, which would then further make it difficult to schedule. So overall, this wasn't really ideal. And this design in theory was a really cool idea, but I think overall it's way too bulky. Another proposed plan that we had, and one of the plans that I showed, was having basically individual pods for source and destination, but having individual worker containers on the pods that essentially having a source worker and a destination worker, instead of having instead of either putting them on the same pod or having worker pods that are separate from the source and destination pods. This is pretty cool because it allows us to avoid creating individual pods for every source destination combination. But this can actually become pretty it actually will become pretty hard to manage, because at the end of the day, we're going to need something that's coordinating between the different pieces. And in the previous example, we had the issue of messaging, of sending data from source to destination, solved by both of the containers being on the same pod. But we still need a worker that's going to be basically coordinating between these two pods, now that they're not in the same location. So we didn't want to have too many unique applications running on these pods, and shared persistent workers is kind of a little complicated because there's actually some security issues with this too. Because one of the things that we were thinking about when approaching this paradigm was that security could actually play an issue here too. When you bring up a sink in the UI, we wanted there to be a direct coupling between a user and what was provisioned. So we didn't want to have to just persist. We didn't want to just have infrastructure that was permanently provisioned and all kinds of different credentials would be going through these source and destination workers. So we wanted there to be a direct coupling between a user and infrastructure that was provisioned. So to clarify this and to I guess make it more clear about like what this architecture would imply is that if you just had let's just say you had Salesforce, like you were syncing data from the Salesforce API. Let's just say you were syncing data from the HubSpot API. And then let's just say you had two destinations. You had a Postgres and a MySQL destination. And let's say you had combinations of syncing of sync patterns. Like you'd sometimes sync HubSpot to MySQL or HubSpot to Postgres, and then also Salesforce to Postgres or Salesforce to MySQL. What would happen is that you'd spin up these permanent source connectors, these permanent pods that would essentially direct all data. Anytime you used a Postgres, anytime you like synced with a Postgres or MySQL destinations, they would go through those pods, and that's why security is an issue in the sense that no matter who's using Airbyte and no matter who's setting up these syncs, we are going to have various credentials pass through those destination pods or the source pods. So security was a bit of an issue here, and we weren't really solving any big problems outside of perhaps scalability across nodes. So that if we were able to solve the node problem, then I think these pods and these containers would be a lot more lightweight. And I guess the big question is like, what did we actually do? And we moved those worker pods outside the source and destination pods. So in the previous architecture example, we had the workers alongside the source and destination containers. And what we realize is that in order for us to be horizontally scalable, in order for us to theoretically one day be able to provision X amount of workers, we need to decouple the workers from the source and the destination. So if you think about whenever you're dealing with any manifest, or whenever you're whenever you're bringing up something on Kubernetes, you want to be able to like specify in your YAML file, okay, how many workers am I bringing up? How many of each thing am I bringing up? How much fault tolerance do I need? And and so it's not very, it wasn't very Kubernetes like to kind of just have this strong coupling between the workers and the source and the source and destination pods. One of the things, and probably one of the most important and kind of the hardest problem that we had to solve, was this idea of moving of that. So if we think about moving the data from the source to the destination, we think about that Airbyte message that we need to send. We need to send the message from the source to the destination, and we got to go through the worker. We need to figure out a way to send this across nodes. We need to figure out a way to securely send this message, to basically securely send this message, and to do it in a lightweight buffer-like fashion. And one of the things that initially came up is that Kubernetes pod logs, using like kind of the logs API for pods, was a very, very cumbersome way of trying to accomplish this. We don't want all of our data stored in logs. A lot of that you absolutely wouldn't want to be persisted. You wouldn't want to essentially have to your logs, your pod logs would become essentially unreadable if you had any actual errors or any important things you wanted to surface. It would be impossible to read through it. So we couldn't have the pods communicating over logs. Additionally, we need to make all of the components except the server and schedulers schedulable on any node. And we configured the server to publish its logs to cloud storage. One of the important things was we wanted people to be able to configure their logging and essentially move their logs outside of Kubernetes really easily. So this is the architecture that we eventually landed on after kind of going through a bunch of those variants. And we, I guess some of the most important points to highlight is that, like I mentioned before, anything is schedulable on any node except for that server and scheduler pod. So again, we want to be taking advantage of basically the scheduling, the essentially like Kubernetes like really powerful ability to schedule evenly across nodes and to handle load across nodes. And so and then we have that server essentially publishing the logs to cloud storage. So logs from various operations are just piped into the scheduler, and the scheduler publishes both of its own logs and the logs of the various worker pods. So instead of having the like I mentioned before, instead of having the workers live on the source and destination, this scheduler pod will work with the temporal cluster pod to bring up Airbyte workers. So they're going to bring up the various worker pods that are going to be responsible for performing the work. So the scheduler pod is also responsible for the various pods lifecycle and for basically reporting successes and failures. If we look kind of deeper into this, we get it kind of becomes a little more complicated, but I guess we can try to kind of break this down. A lot of kind of like the initial architecture that we went into just misses over this huge problem of having the pods communicate with each other. And you can see that we actually did all of this communication through essentially standard out, standard in, and standard error. And we use the SOCAT utility to essentially pipe named files from one pod to another pod via a shared volume. So essentially we have container sidecars with these mounted pipes on those shared volume mounts that I kind of was talking about to essentially simulate basically local communication between these two remote processes. So we want to be communicating our workers with our schedulers. So one of the kind of important things is that, like, so let's just say whenever we want to input configuration for a sink, we wanted to set up a sink, and we want to essentially input configuration for that needs to be sent to the source container. how do we do that? We have to essentially take that config in through the server. That config is essentially handed off to the scheduler, and now we need to pipe that in to the worker pod. So we essentially take that in through that main scheduler process, and we essentially use SOCAT to pipe that into the standard in container. And we have a named file called pipe standard in. That's just essentially a file, and that kind of just that is essentially what goes into the main container. Similarly, whenever we want to ship information out, most importantly, whenever we want to kind of essentially take data out of the source pod and move it into the destination pod, we have to do this not through Kubernetes logs, but through standard out. So if we look at these, if we look at the main container, that's essentially what's going to be handling all this logic, which pushes all of the data into standard out, and then with SOCAT we then push that data through essentially over the network to back to the scheduler, which essentially lets it talk with the server, which is really important because, as we mentioned before, the server and scheduler are located on the same pod. I think this is a bit, there's a lot of moving parts here. If there are any questions about this, I'd be glad to field this, because it's a little, yeah.
I mean, and one thing I just want to know is just because, we often talk about the learning curve for folks that are getting into running data on Kubernetes.
Yeah.
You came at this from a different angle, because you're quite early days if we want to consider what was being done and what's still being done at Planet Scale and Vitesse. We had Alkanon on the meetup. We also had Deepthi in a panel in KubeCon.
Yeah.
Is that for you now approaching this from a different angle? Did you feel like you had to relearn or unlearn, or what was the knowledge acquisition? What was the learning curve like that for you? As a person and also as an organization more broadly with Airbyte?
Honestly, I will say that a lot of it was a lot of the knowledge is actually really transferable once you've worked with the Kubernetes API, and once you've worked with like the language. Like, I think a lot of that initial work was done for me. Essentially, like I if you understand, I guess, the concept of like secrets or volume mounts, you understand like you understand like how logs are published in the API, like with pods and stuff. And you kind of, I guess, once you learn the language, I think that language kind of sticks with you. I was very lucky to, I think, work with Kubernetes at Planet Scale, but there wasn't actually too much I had to relearn because at the end of the day, it's kind of just, I had to learn the Airbyte architecture, and then we kind of just had to map that to stuff that I already knew. But I will say that the learning curve when first trying to get into, I guess, writing with the Kubernetes API, that was massive. I actually don't think it would have been possible at all if I didn't have really good mentorship, because I think I was just lucky I honestly think I was lucky because I happened to be coworkers with one of like the founders of the Kubernetes project. So Anthony Ye, who's like,
that helps.
who he's like one of the most legendary engineers ever. I actually essentially just got to ask him any questions that I wanted, and he essentially helped write it. So I guess that I don't want to like kind of say that it just all came naturally. It was a very difficult learning process.
No, but I think it's a lesson that we've heard on other occasions, most poignantly from Salman Iqbal, who did a live stream with us about backup and restore, is that if you only treat Kubernetes as a technical challenge, you're gonna have a lot of problems. If you treat it as a challenge of establishing a good network of folks who can help you out, you're gonna have a lot more success. So yes, by circumstances, you happen to be with someone who had that experience. But most of all, making mentorship a factor so that you don't have to suffer so much on your own.
Yeah, absolutely. I think it's really important. Especially with when we kind of get into the weeds here with stuff like this. I know maybe like a few people will I guess be able to nerd out and understand, and I guess kind of like be able to dive into the stuff. But I think, which is why I want to kind of like make sure that I'm covering all my bases here. But I guess to kind of like jump back into this,
Go for it.
I think if I just to cover all my bases, I want to essentially restate why we need to be able to really think about moving data across pods is because as an ETL, as an ELT like product, we need to be able to make sure that we're essentially moving data when we take it in from the connector pod. And as it goes to the worker pod, we need to have a really good story around like how that data is moved. And on Kubernetes, it's not necessarily straightforward to move the data. So just to restate that problem statement. And so that's why essentially we are essentially sending it over this network with that SOCAT utility. And that's why we're essentially using these local files. We're using this shared volume mount that essentially allows us to, I guess, essentially use these files as buffers. So the data will go into these files and then they'll get pulled straight out with SOCAT, and they get sent over the network back to the scheduler pod. So and I guess a question that someone could ask is like, could you do this with config maps and or could you handle file transfer with config maps? And no, or like in terms of like handling the config with the standard, when we're talking about the standard in processes, and the answer is no, because a lot of the files that we're sending into the source connector for configuration are going to be too big for config maps. So I guess to summarize, we have a sidecar on essentially on this pod that wraps the entry point to write standard out to essentially local named files. And these local named files, as shown, are /pipe/standard out /pipe/standard error. So, and then the sidecar then on the server relays that information essentially back all the way to the essentially to the scheduler. And if we think about then, if we go into the life cycle, going from start to end, basically, if the first thing that happens, scheduler receives an API call, we're going to the scheduler essentially needs to either basically just needs to execute a job. We then, I guess, essentially extract that entry point. The extracted entry point is then piped back into the scheduler, and then we allocate the ports, and then we, using the entry point and the allocated standard out and standard error ports, the scheduler configures the worker pod and instructs Kubernetes to create these worker pods, and then the worker pods create. We have and then we create those mounted pipes once the init container starts on the worker pod, and then the scheduler will wait for the init container to begin, and then starts copying data over this shared volume mount. And that's kind of like the main part of the life cycle. And then essentially and something actually I want to talk about really quickly is that we have this heartbeat container here on the worker pod that is constantly checking to the scheduler, making sure that that the scheduler is alive. So as long as the scheduler is alive, this worker pod will continue to I guess to function. One of the important parts is that we don't want a bunch of zombie pods being created and being left around. So we're constantly kind of pinging back to this heartbeat server process that's happening in the scheduler to make sure that we don't leave a bunch of zombie pods while running a bunch of syncs. And one of the interesting parts is that we kind of immediately, so that was the architecture that we came up with about I think 3 or 4 months ago, and we immediately realized that there was a huge issue in terms of horizontal scalability. we realized that we wouldn't be able to configure workers, or we wouldn't be able to essentially scale workers horizontally. So we actually split the scheduler into a scheduler and a worker. So essentially the worker, before, if we look back here, that worker pod that we just described was living, or so that worker container was living essentially, and all of that work was living inside of the scheduler pod. So we realized there was this tight coupling between how much work we can spin up and how much, and we didn't want to have to like essentially replicate a bunch of the scheduler pods, because we don't need more schedulers, we just need more workers. So we actually split our scheduler pod up into the worker pod and the scheduler pod. And so we were able to kind of like horizontally handle load for work that comes in, and you can now scale out your syncs across different nodes. You can scale out your sync. You can scale out basically how many resources you're applying to your syncs, and there's actually still some work that needs to be done here. So if we think about the future, currently you can only define how many worker pods you want. You can go in and you can say, hey, I want maybe like 5 worker pods or 6 worker pods, depending on how many syncs you think you're going to be running. In the future, one of the things we're looking forward to is just being able to kind of auto scale this and have each sync kind of have essentially bring up worker pods, a dedicated worker pod for each one of these syncs. So that was kind of a lot. I kind of went all over the place. I just want to make sure that that we covered, I guess, enough things to kind of.
I don't think anyone's disagreeing with that. No, you went for it, man. That's good.
So I think one of the things to, if I were to sum all of this up, is that we had this idea of essentially, if we had this idea of initially of having the our source and destination containers located on the same pod. Then we said, okay, this doesn't really take advantage of scheduling. So we're making sure, okay, how do we take advantage of Kubernetes? Okay, let's split them out and have the source and destination connectors on different pods. And of course, there's going to be issues with handling messaging across the pods, which we eventually solve later. But we then need to we need to include a worker pod to kind of handle the messaging between the two. So then we kind of essentially realized that, okay, wait, there's going to be a lot of these. There's going to be a lot of moving parts. So yeah, let's move that worker pod out. Let's make sure that we can schedule everything on, like, essentially be able to schedule everything on different nodes. And then we ran into the issue, okay, how do we make the pods communicate with each other? And that's when we essentially figured out, okay, kubectl logs, pod logs are really not a good way to have like containers communicate with each other. And we essentially just need we just need to send a data into a buffer and it to be essentially just read into another container. And it just needs to be as simple and lightweight as humanly possible. What do? We use this shared volume mount. We essentially have we essentially have this wrapper entry point or like around our workers, and we essentially make sure that any data that gets sent from our connectors or gets sent into our connectors is handled through these shared volume mounts and is handled with SOCAT. And if any of this isn't very clear, I can send you the we can follow up after this. We can and we can send you the documentation on this. And so once we handled messaging between pods, we then need to make sure, okay, how do we make sure that zombie pods are cleaned up? And that's where this parent-child architecture comes in, where we have this heartbeat server process that we mentioned here in the scheduler. We have that's constantly sending a signal, and once that dies, the worker pod immediately knows to basically go down and fail. And so that's how we make sure that we don't have worker pods that are kind of just outstanding. And for the future, we plan to have these worker pods be kind of like an auto-scaled, have like an auto-scaling situation instead of just having like a static number that you set in a manifest. So overall, it's a lot. There's kind of like a lot that went into this. The kind of concept around using that shared volume mount is a pretty unique one. I think when our engineers were thinking about how to do this communication between pods and how to be like basically be sending large amounts of data across pods, this is kind of like this was kind of a solution that they came up with. This wasn't something that kind of we took off the internet or was standard practice. We just found that, okay, this is actually the most efficient way to basically move data across in Kubernetes. And eventually we want to make sure that all of these syncs are independent entities and that everything should be able to run autonomously. So I kind of just want to stop there, give Bart, if there are any questions, I'd love to take them. Also, if you have any questions, I'd love to answer them.
Yeah, I mean, there is a lot to unpack here, and yeah. I think some folks will definitely want to take a closer look at the slides. Mm-hmm. I think we're at live stream number 99, so we've heard lots of different perspectives on running data on Kubernetes. A lot of what's still agreed, though, is that so much of this stuff is being done for the first time. So I really like that point that's being mentioned there, is that everything should be, this is kind of what a lot of people say is, can we please make this boring? Because right now it's kind of a Wild West sort of scenario. But as more use cases come out, as more folks are able to share their experiences, as you've just done, there's more and more of a method to the madness. Based on what you've learned, what recommendations would you make to other companies, other folks that are out there that are going to, because it seems, this is the trend. There are different reasons as to why people are going to run their data on Kubernetes. We can get into that later. But for folks that are going to start doing this, in the case of Airbyte, having done it, what would be advice, pointers, things that you would give to other folks that are out there that want to start getting more involved?
I think one of the most important things is first figure out like how Kubernetes ready you are, because I think that was the first thing that we ran in that we asked ourselves is like, okay, can everything be split up? Can we comfortably run things in separate nodes? Can we handle networking across nodes? And are all of our processes are they cleanly containerized? Can they be cleanly run as individual pods or as co-located containers on a single pod, right? So I guess the biggest question I think is if you ask yourself that and you say, oh, hey, we have a bunch of just easily really simple lightweight containers that can easily that don't need to do like a bunch of high traffic networking across and kind of just need like really simple communication and can totally live on different nodes and everything is containerized, then it's kind of a no-brainer, but that's kind of I guess a rare case.
Yeah.
So in that case, then you'd say, okay, maybe this makes sense. And then once you kind of but before you actually try to I guess implement in Kubernetes, the biggest thing I think I would say is just make sure that you're ready. I don't think I could speak to any of the specific implementations because obviously I didn't do this myself. There's a lot of because it's so new, there's going to be new things that come up. You just have to be prepared to kind of tackle problems like this in unique ways, and that's not something necessarily that you can write a course on. You can't go to Coursera or
not yet at least.
Yeah, not yet. And so I guess the biggest thing that I can probably speak to is just about the preparation. If you can do any prep work to make your life easier before trying to kind of support Kubernetes, I think that's probably the biggest thing. Make sure that your architecture is really benefited by it. especially because remember that point I was making earlier about, let's just say we ran everything on one pod, right? Let's just say we ran our source container, our destination container, and our worker all in the same pod, right? It's like, what are we really taking advantage of Kubernetes there? Like the only reason, I think the only purpose that I guess we would want Kubernetes support there is just to support people who are only using it. And so, but anyone who isn't using it would look at that and say, okay, I just kind of need a big VM to run this, like why would so really you have to like ask the question is like, are you really taking advantage of this like really powerful orchestration service or like and if the answer is no, then I think you should kind of like keep it simple, right?
Yeah.
So when we think but the thing is that in our case, we have so many moving parts and so many things that can be split up and can be scheduled onto different nodes and can be run in parallel and can be like basically auto scaled, brought up, brought down, and so it's a perfect use case for bringing it onto this massive orchestration platform. But there were, as I mentioned, some issues to kind of go through.
One question that we got from the audience, for the heartbeat, are you just probing a named port on the worker? Can you please talk a bit about its implementation?
Sure. I can't speak to the exact implementation, but essentially what's going on is that we have essentially we run a server process on the scheduler pod. So, and this is and it's kind of just spitting out a message at an interval, and whenever I believe it's just kind of like there's just like a TCP connection that's going on there, and whenever the scheduler doesn't reply in that, then the heartbeat container terminates the worker pod. I think does that answer the question? But yeah, there's just a server on essentially a predetermined port that is, and they're just, and whenever the scheduler doesn't reply on that port, the worker pod's immediately terminated.
Very, very good. Fair enough. We're just about out of time, but one question that we're starting to ask all of our guests now is that if you had to run data on Kubernetes with any person or fictional being, since we could maybe incorporate a little bit of Smash Brothers here, who would it be and why? Who would you want on your data on Kubernetes team?
Who would I want?
Yeah.
Maybe so we have to think about this, right? Who would be able to manage like who would be able to manage large platforms and delve into, and so someone adventurous, right? We need someone adventurous.
Who's gonna see this slide and be like, I'm jumping right in. I'm going for it. Like I'm all in. Maybe I don't know. Maybe Link. He's good at puzzles. He's adventurous. I feel like he'd be a good pick for this. Link from Legend of Zelda. I'll go with that answer. All right, that's a solid answer. I respect that.
Yeah.
Last thing we got to do before we finish. Can you stop sharing your screen really quick so I can share mine?
Sure thing.
Yeah, we weren't able to incorporate Link just yet, but don't worry, Link will have his day. But while you were talking, we have our amazing graphic recorder who's lurking in the shadows. Let me know when you can see my screen. You should be able to see it.
Awesome.
Yes.
That's super cool.
So I did let him know that you were a super Smash Brothers fan. So we got Mario in there. Not as much action and combative sort of stuff that we would as like to see with Smash Brothers.
That's amazing.
But anyway, Abhi and I hopefully have a pending collaboration related to music that will be coming out maybe in 2021, if not 2022. So stay tuned for that. Any other Airbyte news that you'd like to share before we finish?
Sure. I mean, we have our Hacktoberfest that's going on right now. So if you come in and develop a source connector or destination connector, you can get some cash prizes. We are essentially really trying to get people into connector development right now. All that stuff that that I mentioned is not essentially. I guess it's none of that complexity exists when you're just developing these individual connectors. Like I mentioned, the individual connectors are really kind of like isolated pieces of code, and developing them for different data sources and different data destinations is really important as we're trying to like if we're trying to like fill out, okay, can people move data from anywhere to anywhere, right? We need to be able to support everything. So we're just kind of trying to work with the community, work with everyone to, I guess, solve that problem together. And so that's essentially what we're focusing on right now. I guess look at in the future for Airbyte Cloud, which is going to be going to come to the public in North America pretty soon. So
all right. So plenty of things, but never a dull day in Airbyte.
Nope, never.
If today was your first time hearing about Airbyte, you will definitely be hearing about it again. Thanks so much for joining us today, Abhi. Always a pleasure having you with us, and looking forward to the next steps. Like we said, very easy to get in touch, either Twitter, LinkedIn, our Slack, the Airbyte Slack. Just reach out and say hi. Very friendly folks that will help you out with whatever you need, as long as it's related to the topics we were talking about today. Thanks a lot, man. Have a good one.